So welcome back, ladies and gentlemen. This is again Tuesday, February the 23rd. We're going to look at radical systems from your package. One of the fundamental rules that we're going to look at is changing from what's called entire radicals to mixed radicals, and mixed radicals back to entire radicals. This is actually a lot of students have been taught in grade 10, where the product of the radicands, when multiplied, gives us the entire thing underneath that radical symbol. Now the skill set we're trying to show you is that we're basically trying to have a number that's all underneath the radical sign. And so this is a property where you can multiply them out. And some people actually want to know what's a mixed radical. A mixed radical has a whole number and a radical component. And usually, we try to find the largest perfect number. Largest perfect number. What does that really mean? Well, basically, we're going to look at example 1. And notice this is root 75. That's how you say this, root 75. So some of you might remember, maybe I did this, maybe I didn't. The numbers that I'm going to write down here, hopefully I don't forget one. These numbers are the perfect terms. 1, 4, 9, 6, 21, 32. I think I did them all. 1 times 1, 2 times 2, 3 times 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 11, 12, 13, 13. So notice what we're going to try to do. We're going to try to think of the numbers when multiply give us 75. Now the largest perfect number that goes in there is 25. So 25 times 3. So notice what this looks like. This looks like root AB. You see that? But then, and I like breaking it up this way, according to this portion, and again, I'm not lying to you, this rule is important. So you might have to memorize it. It's one of the formulas. It pops up a lot over and over again. Notice what I did? I wrote root 25 and root 3. So what is the square root of 25? The square root of 25 is 5. And how do you say this? 5 root 3. This is not like a mixed fraction. This is a mixed radical. It has a whole number and a radical component. A mixed fraction is actually addition, whereas mixed radicals is multiplication. Notice what I'm going to do, even though question C is there, I'm going to take a look at this mixed radical, and we're going to go from mixed radical to entire. So we're going to kind of go the reverse. And again, what I like doing is, some of you do it differently, and it's okay. I don't really care how you do it, but some students realize we translate the 4, and we try to put it under a radical sign. And the only way to make a 4 under the radical sign is make it equivalent. So the squaring of 4 is 16. And again, I know I'm going slow. Some of you say, Mr. Chen, this is too silly. Why don't I just jump to it? I'm just trying to help everyone out. If we have two radicals, we can multiply them to be together. And then 16 times 2? Root 32. And that's how you say this. Notice, these are what's called exact answers. Some students still have difficulty why we teach this. Exact answers are fractions, radicals, pi, etc. So a lot of students find this difficult. You should have seen this in grade 9, especially when you're dealing with circumference or perimeter, sorry, circumference or area of a circle. Right, so we might have left things in pi units. An approximate answer is usually a decimal answer. Some students still find it difficult. Okay? The decimal answer is actually very useful for word problems, but when we deal with math, the exact answer is important. Again, some of you find it awkward, but there's a reason. And again, I don't know what the square root of 32 is at decimals, and I don't care. We don't normally teach that anymore. We don't teach you the long-winded way to evaluate these radicals. I wish I could show you, you would hate it. I had to be taught it, and then you have calculated for that. Same thing with root 3. I have no idea what that answer is. Who cares? You can use your calculator. Okay, so let's go to question C for example 1. This one's a little strange. You might not have seen it in grade 10, so don't feel bad. This is the square root of 2 over 9. And watch what I can do. Again, it's in your handout. I can actually break this radical like so. Root 2 over root 9. Can someone help me out? No one actually know what the square root of 9 is? Top of their head? You have to use the calculator. Kai? It is 3. In some students in Mr. Chen, that doesn't look like a mixed radical. It looks like root 2 over 3. It is correct. It doesn't look like that. So watch what I'm going to do. Don't get me wrong. Most students will answer this. This is the same. And notice, now we have a mixed radical. This is a number. You know it's a rational number. And this is a radical. But that's how you say this. These are all the same. And that's the answer for this. This one's a little bit trickier. Notice this is negative 6 root 5. This one's a little tricky, so you might want to put a star just to make sure you can grasp it again when you're doing your work at home. I would recommend that you factor out a negative 1 first. So negative 1 times 6 root 5. Everyone see what I just did there? This one's a little tricky. If you do it exactly the same like this, you're not going to get the same answer. Watch what I'm going to do. I can still leave that negative 1. And 6, when you square it, is 36, right? Everyone see that? So root 36 times root 5. And again, don't feel bad if you needed to, you look at these perfect numbers. 36 times 5, I think it's 180. Can someone double check if you had actually, I'm pretty sure it's 180, but thanks. I actually don't know. Someone in the other class told me. So this is that. And if you don't like the negative 1 there, that's that answer. Negative root 180 as an entire radical. So example 2 there. Let's pause for a second. Any questions right now from the examples? So hopefully some of you do remember doing this, especially for exact answers. I know for a fact, I think some teachers decided to wait till the quadratic unit to teach it, whereas normally when I teach grade 10, I always teach this when we had unit 2 with the coordinate geometry. So if you didn't really learn this, and I don't know what to say about your teacher. Anyways, example 3. This is probably our last example before I stop the video and answer any questions, because I want to talk about stuff and move on. This is 9 root 2 times 4 root 7. So how would I do this? Again, some students would say, well, Mr. Chen, don't I change it to entire radical, change it to entire radical? And the answer is no. For this example, I'm going to multiply these two together, the 9 and the 4 together, and then I'm going to multiply the root 2 and the root 7 together. Because multiplication is commutative. You can multiply anywhere you want. So 9 times 4, that's 36. What's root 2 times root 7? Again, root 2 times root 7. Notice I can do that. Put it under the radical sign. So that's going to be root 14. And that's the answer. That's the answer. Now, let's take a look if we had this question. I'm going to change this up just a little bit. Let's say it's 9 root 2 times 4 root 2. And let's just say, and a lot of you can already see this. This is actually a little easy. So maybe I should change it to something like this. 9 root 2 times 4 root 8. Okay? So I think we're going to do the same thing. We're going to get 36. And then root 2 times root 8, that's root 16. Now if you stop here, it just means you don't have a good number sense. Can someone help me out though? What's root 16? Try again.
4.
It is 4. And whatever that is. I don't even know. 24, 12, 144. So notice, if you stopped here, and it's a good answer to stop at 36 root 16. Root 16 is actually 4, and then now you can do it. You tend not to need a calculator for this. However, it's there. Example 4 and 5 for those people that are watching at home. And example 6 we're going to do in a moment, but I'm going to just pause the video here because this is a good part to break.